Wood is a precious resource, and harvesting it properly is an art. Join LumberPro to discover the technology, techniques, and interesting stories behind each tree. When climbing steep slopes, log trucks face the risk of losing momentum or sliding backward if the road is too slippery. The driver must stay in a low gear to maintain traction and carefully control the throttle to prevent the wheels from spinning in place. On steep inclines, trucks may need to ascend in a zigzag pattern instead of going straight up, reducing the effective slope and improving grip. If the incline is too steep or the soil is too soft, a bulldozer or another truck may need to push from behind for assistance. In some cases, the driver might have to reduce the load, making multiple smaller trips to ensure safety. If the truck starts sliding backward, emergency brakes and wheel chocks made of wood or rocks can help prevent a dangerous descent. Forest roads often have sharp turns, with narrow paths and no guardrails. When approaching a turn, the driver must slow down early and steer gradually to prevent the truck from tipping over. On dangerous curves, logging trucks require extra space to maneuver. If the road is too narrow, a clearing vehicle or reversing may be needed to adjust the turning angle. Some trucks are equipped with hydraulic steering assistance to make handling easier on rough terrain. When log trucks travel through forest roads during the rainy season, the road surface becomes muddy and slippery. The wheels can sink deep into thick mud, causing the truck to lose traction. Sometimes, the wheels spin without moving forward, forcing the driver to use a winch or seek help from a bulldozer to escape the mud pit. Deep mud sections often have ruts formed by previous trucks, making it difficult for following vehicles to stay on track. The driver must constantly adjust the steering wheel to maintain balance and avoid slipping sideways. If the mud is too thick, reducing tire pressure or using chain tires can improve grip. On dangerous curves, logging trucks require extra space to maneuver. If the road is too narrow, a clearing vehicle or reversing may be needed to adjust the turning angle. Some trucks are equipped with hydraulic steering assistance to make handling easier on rough terrain. The log splitter roars to life with a deep engine hum. The hydraulic press slowly pushes the log against a razor-sharp steel blade. A sharp crack echoes as the wood splits in half, then continues to break into even, symmetrical pieces. The sound of cracking wood reverberates through the quiet surroundings, each split like a small thunderclap in the forest. The air is rich with the scent of pine resin and fresh timber, creating a deep sense of connection with nature. The blade is crafted from hardened steel, sharpened and treated to endure extreme force. It comes in various shapes: V-blade, cross-blade, or spiral designs that split wood into 2, 4, or even 6 pieces. Thanks to this design, the splitter can tackle dense logs like oak, mahogany, or eucalyptus. The log splitter reduces manual labor while eliminating the risks associated with axe use. By recycling wood scraps into fuel, it minimizes waste and maximizes forest resource use. It's an eco-friendly and cost-effective solution for both households and small-scale producers. The log splitter saves a significant amount of time and effort compared to manual splitting. With powerful hydraulic pressure, it can process dozens of logs within minutes. This not only reduces the risk of injuries from using axes, but also greatly boosts work productivity. Additionally, it produces evenly sized wood pieces, which are easier to stack, transport, and burn efficiently. Despite its efficiency, a log splitter can be dangerous if not used properly. The powerful moving parts can cause serious injuries, especially if hands or clothing get caught in the mechanism. Wood fragments may fly out during splitting, posing risks to the eyes and skin without proper protective gear. The machine can also slip, lose control, or malfunction if placed on an unstable surface or not maintained regularly. The sharp metallic scream cuts through the stillness, scattering birds into the sky. Trees that have stood for decades, even centuries, now begin to lean under the saw's rhythm, crashing to the ground with a deep, echoing thud. The chainsaw blade meets the dry wood surface, then plunges inward with sudden force. A screeching sound erupts, high and metallic, like a steel horn. Layers of wood are torn apart, sawdust flinging into the air and swirling like pale dust in the wind. The chainsaw doesn't hesitate. It presses forward steadily, its motor deepening in tone with every centimeter. The rotating chain moves like a relentless machine, slicing through the dense grain of the wood. A rhythmic roar pulses like a mechanical heartbeat, occasionally punctuated by sharp clack-clack sounds when striking hard knots. The blade leaves behind a smooth, deep groove, and light smoke rises from the heated wood, carrying a faint charred scent, raw and earthy. A crisp crack rings out as the wood begins to split. The chainsaw keeps spinning, as if urging the break to complete. Thick sawdust flies in the heated air, veiling the surroundings in a golden haze. The freshly exposed wood is brighter, smoother, with swirling grain patterns. Chainsaws allow users to cut trees, branches, or large logs much faster than manual saws. Thanks to their powerful motors and sharp chains, they can complete tasks in minutes that would otherwise take hours. This makes them essential in forestry, construction, and post-storm cleanup. Chainsaws can cut through thick, hardwood or large diameter trees that other tools can't handle. High-powered models can even slice through trunks over half a meter in diameter. This boosts productivity in lumber processing, material preparation, and professional forestry operations. Chainsaws are heavy and generate intense vibrations. If the operator lacks strength or works on uneven ground, they may lose control, drop the saw, or accidentally cut themselves. Prolonged exposure to vibrations may also lead to hand-arm vibration syndrome, HAVS, causing numbness and long-term hand damage. After logging, large tree stumps remain as obstacles for reforestation or land repurposing. To remove them, stump grinding machines are used to grind and level the remaining stumps, making the ground smoother and more usable. A stump grinder consists of a large rotating disc fitted with sharp cutting teeth. When activated, the disc spins at high speed, gradually grinding the stump into fine wood chips. Powerful hydraulic systems enable the machine to maneuver over rough terrain and precisely target the stump. As the machine approaches the stump, the hydraulic arm adjusts the grinding position. The cutting teeth begin slicing through the stump layer by layer, producing a distinctive grinding sound. Wood chips and debris scatter around as the stump is gradually ground down to soil level, leaving behind a fine layer of mulch. Challenges in using stump grinders. Large stumps with deep roots. Some old stumps have extremely strong root systems, requiring longer grinding time. Uneven terrain. Operating on rocky or sloped surfaces requires advanced balance systems to prevent machine slipping. Wood debris and dust. The grinding process generates a lot of wood chips and dust, which can obscure the operator's vision. Benefits of modern stump grinders. Fast and efficient, can grind dozens of stumps per day, saving significant time compared to manual digging. Environmentally friendly. Instead of burning or using chemicals, stump grinding provides a cleaner removal method. Increased safety. Remote control systems and automated features minimize workplace hazards. Follow the channel to explore the world of logging. Don't forget to like and subscribe for more exciting videos.